In this tutorial, we'll be looking at the difference between static values and dynamic values. To understand the difference between these two, think of static values as any quantity that has to be updated manually if there's been a change to the project's design. On the other hand, dynamic values are those quantities that we derive from quantity formulas that automatically capture changes to the project's design. As you can imagine, dynamic values save us a ton of time as we go through geometry iterations for a project. To illustrate this, let's look at the difference between how I calculate miscellaneous metals and metal decking detailing. Both of these quantities are calculated on a per square foot basis, so I need to find the total area of our project. I'm going to create a static value for miscellaneous metals. So, to find out the total area of our project, I'll consult the area sheet, I'll scroll down to the bottom and find that we have 225,000 square feet. I'll return to the line items page, and I can enter that static value either by typing on my keyboard 225,000 and hitting enter, or by hitting equals and then enter and being prompted with the pop-up. The two static values in our add values window are metric and number. The difference between these two is that number will allow you to input a value, but it will not have a unit of measurement. Metric, on the other hand, allows us to input a static value and type anything we want for our unit of measurement. I'm going to hit save, and now we have a static equation in miscellaneous metals. To contrast this, let's create a dynamic equation for metal deck and detailing. I'll add my quantity formula, and I'm going to tie to our area sheet by selecting area. As you can see, the default is total area. So essentially, our work is done. I'm going to hit save, and now any changes that we make to the area of this building will be automatically captured in metal deck and detailing, whereas those changes will have to be made manually for miscellaneous metals. To illustrate this, I'm going to delete level 10, and we can consult our line items page and see the difference between metal deck and detailing, which has automatically captured our changes, and Miss Metals, which has not. Now, as you can imagine, the more dynamic formulas we have in our estimate, the less time we need to spend checking for human error. If we change this equation to a dynamic equation, the area of our building will be automatically captured, no matter what. Another helpful tip when tying to the area sheet is that you don't have to only tie to the total area of the building. A typical example might be when calculating metal deck and detailing, there may be a floor of the building which does not receive metal deck and detailing. If this is the case, we should return to our metal deck and detailing equation and tie the equation to specific floors rather than just the total area. It's not uncommon for the first floor to be a different material than the rest of the building. So, if we were to rewrite this equation, we might want to capture from level 2 to the penthouse. Something to be careful of is that because we've tied this to specific floors, changes to the building outside of these specific floors will not be captured. To illustrate this, let's change miscellaneous metals so that it mirrors, but captures any changes outside of this. I'm going to hit save and return to miscellaneous metals. Now, let's say that we want to exclude the first floor from receiving this Miss Metals allowance. I'm going to select level 2 our specific floor that we want to start at, but rather than selecting penthouse, I'm going to choose highest floor, so that if we make any changes to the height of the building and add or subtract floors, those changes will be captured. To show how this works, I'm going to hit save. From here, we'll go to the area sheet and we're going to make some changes that will be reflected in the difference between miscellaneous metals and metal deck and detailing. When I go to area, if I choose to delete the penthouse level and return to the line items page, you'll see that our blue potion icon has become a red potion icon in metal deck and detailing, whereas our miscellaneous metals equation appears to be working just fine. The reason why we have received this red potion is because the specific floor that we have tied to has been deleted. Now, to change this, I'm going to tie it to the next highest floor and hit save. We've fixed our equation. The problem, though, is that this equation is still not going to capture any changes to the geometry of the building on those upper floors. If I were to go back and re-add the penthouse level, and return to our line items page, you'll see that that penthouse level has been captured in our miscellaneous metals because it is tied to the highest floor rather than a specific floor. And when we return to our metal deck and detailing, you can see that because we've tied to a specific floor, any changes to the building above that, like adding a penthouse, will not be captured in our equation. There are many other types of values that you can add that will help you create dynamic equations. You can tie to other line items in the estimate. You can tie to the geometry worksheet. You can tie to units and anything within those units. You can also tie to rooms in your finish schedule and anything about the geometry of those rooms in your finish schedule. And you also have the ability to tie to active floor, vertical transportation, and attributes of the project. Understanding how to write and edit dynamic formulas is one of the most important skills that an estimator can have while using CostLab. This allows us to save time during the design iteration process and prevent us from making mistakes when manually entering quantities. There are many ways you can use dynamic formulas throughout CostLab, too many to discuss in a video like this. So for further details on those more advanced topics, there will be future videos that you can consult. Thanks for watching.